Hello, my name is Hsieh, and today I'll be presenting research that I'm doing regarding the potential effects rock dam detention structures have on recharge of groundwater. Some of you may remember me from last year for my presentation about the decline in groundwater levels in Wilcox, Arizona. This research is a continuation of that presentation. Where we last left off was that Wilcox was using up groundwater faster than it was replenishing it, and that the use of rock dams may be one possible way to improve recharge rates of the groundwater. So to better understand the effects of these rock dams, I am researching them in two ways. First, using isotope and water chemistry analysis, and second, through modeling using Hydrus 1D through Python. I'm going to give a quick overview on how water chemistry data and isotopes can help us learn more about our water. For water chemistry data, we are looking for major cations and anions dissolved in the water. The longer groundwater has been in contact with organic matter and geologic compounds, the more evolved the water chemistry will become. This means that we expect the longer that groundwater interacts with its surrounding, the more its ion concentration would change. Now on to isotopes. A specific atom contains a set number of protons. However, the same atom can contain different numbers of neutrons, and we refer to these atoms as isotopes. Consequently, isotopes have different masses from one another, and heavier isotopes are found in disproportionate amounts in liquid and solid states, while lighter isotopes are found in higher concentrations in gas states. This behavior is called isotope fractionization, and it can provide us with information to determine the sources of water. Additionally, some isotopes are radioactive, meaning they undergo radioactive decay, transforming into different atoms over time. Radioactive isotopes can be used to date the ages of water. In this study, we used tritium. 6 water samples are taken from 4 different locations presented here in this map. We'll be analyzing the samples to better understand their origin, residence times, and flow paths. Our preliminary isotope data, we can see that our samples contain some tritium, indicating that they were all composed of some amount of modern recharge, meaning water that's less than 60 years old. Now, the isotope data can only take me so far. The second part of my research is using Hydrus 1D to model different soil compositions, rain events, and initial conditions to determine the theoretical magnitude and timing of rain events that allow for recharge at varying depths. This will allow us to determine theoretical recharge rate where the isotope and water chemistry data may not. Using the physical data and modeling data, we hope to be able to provide a more complete picture of the effectiveness of rock dams and how best to use them to mitigate drawdown of groundwater. Thank you all for attending my presentation, and for anyone who is interested in the results of this research, I invite you to follow along for when I will defend my thesis this coming April or May. Thank you, and I look forward to answering any questions you may have.